A helicopter is one of the most advanced flying machines ever created by humans. Unlike airplanes that need long runways to take off and land, helicopters can rise vertically into the air, hover at one place, move sideways, and land in very small spaces. This special ability makes helicopters extremely useful for rescue missions, military operations, medical emergencies, transportation, firefighting, and exploration. But building a helicopter is a long, complex, and highly technical process that involves precision engineering, advanced materials, and strict safety testing. From the first design sketch to the final flight test, every step is carefully controlled to ensure performance, durability, and safety. The helicopter manufacturing process begins with research and design. Engineers first decide the purpose of the helicopter, such as passenger transport, military use, cargo lifting, or medical evacuation. Based on this purpose, they create digital blueprints using advanced computer-aided design software. These digital models allow engineers to simulate airflow, stress points, vibration behavior, fuel efficiency, and weight distribution. Aerodynamic performance is especially important because the rotor blades must produce lift while staying stable under extreme forces. Hundreds of simulations are performed to improve efficiency and reduce noise, vibration, and fuel consumption. Once the design is finalized, material selection becomes the next critical step. Helicopters must be strong yet lightweight. To achieve this balance, manufacturers use aluminum alloys, titanium, carbon fiber composites, and high-strength steel. Carbon fiber is widely used in rotor blades and fuselage panels because it is lighter than metal and extremely strong. Titanium is often used in engine mounts and transmission parts because it can handle high temperatures and stress. Each material is tested for durability, corrosion resistance, and fatigue life. After material preparation, the manufacturing of individual components begins. The fuselage, which is the main body of the helicopter, is built first. Large metal or composite panels are shaped using precision cutting machines and molds. These panels are then joined together using rivets, bolts, and aerospace-grade adhesives. Robotic arms are often used in modern factories to ensure perfect alignment and uniform quality. Inside the fuselage, support frames and bulkheads are installed to provide strength and structural stability. At the same time, the rotor system is manufactured. The main rotor is the most important part of a helicopter because it produces lift and controls movement. Rotor blades are created using layered composite materials that are pressed and cured in high-temperature ovens called autoclaves. This process makes the blade strong, flexible, and resistant to fatigue. Each blade is carefully balanced so that it spins smoothly at high speed. Even a small weight difference can cause vibration and mechanical damage. The rotor hub and mast assembly are also produced during this stage. These parts connect the rotor blades to the transmission system. They must handle extreme forces because the spinning blades generate massive centrifugal loads. Precision machining is used to create gears, shafts, and bearings that meet exact tolerance levels. Any small defect can lead to serious mechanical failure, so quality inspection is extremely strict. Next comes the engine manufacturing or installation stage. Helicopters usually use turbine engines because they provide high power with low weight. These engines are built using heat-resistant alloys and ceramic coatings. Inside the engine, multiple compressor stages increase air pressure, while combustion chambers burn fuel to create hot gases that spin the turbine. This spinning energy is then transferred to the main rotor and tail rotor through the transmission system. The transmission system is another critical component. It reduces the high speed of the engine to a lower speed suitable for the rotor blades while increasing torque. Gearboxes, shafts, and couplings are assembled with extreme precision. Lubrication systems are added to reduce friction and heat. Engineers test the transmission system under heavy load conditions to ensure reliability and long service life. Once the fuselage structure is complete and major mechanical components are ready, the assembly phase begins. The main body is moved to the final assembly line. First, the engine is installed inside the fuselage using vibration damping mounts. Then the transmission system is connected to the engine and rotor mast. The tail boom is attached to the main body, and the tail rotor assembly is installed. The tail rotor is responsible for counteracting the torque produced by the main rotor and providing directional control. After the main mechanical installation, the helicopter's internal systems are added. These include electrical wiring, flight control cables, hydraulic systems, fuel lines, and cooling ducts. The electrical system powers navigation instruments, cockpit displays, communication equipment, lighting, and onboard computers. Hydraulic systems help pilots control rotor pitch and movement with less physical effort. Fuel tanks are installed with safety valves and leak protection systems to reduce fire risk. The cockpit is assembled next. This is where pilots interact with the helicopter. Control panels, digital displays, navigation screens, radar systems, and communication radios are installed. Modern helicopters use glass cockpits that replace traditional analog gauges with digital screens. Flight control sticks, pedals, and collective levers are carefully adjusted for smooth and accurate operation. Ergonomics is important because pilots must remain comfortable and focused during long flights. After the internal systems are completed, the exterior finishing process begins. The helicopter body is cleaned and prepared for painting. Special corrosion-resistant primers are applied first. Then multiple layers of paint are sprayed using controlled environments to achieve a smooth and durable finish. Military helicopters may receive camouflage coatings, while civilian helicopters often use glossy finishes and company branding. Protective coatings are also applied to prevent damage from UV radiation, moisture, and extreme temperatures. Next comes the installation of landing gear or skids. Depending on the helicopter type, it may use wheels or skid-type landing gear. These parts are designed to absorb impact during landing and provide stability on different surfaces. Shock absorbers and support struts are tested for strength and durability. Once physical assembly is complete, the helicopter enters the testing phase. This is one of the most important stages of production. Engineers conduct ground tests first. These include engine startup checks, electrical system verification, hydraulic pressure tests, and rotor rotation tests. The helicopter is anchored to the ground while rotors are spun at full speed to check for vibration, noise, and mechanical stability. After successful ground testing, flight testing begins. Test pilots fly the helicopter under controlled conditions. They check hovering stability, climb performance, turning response, braking capability, and emergency procedures. The helicopter is tested in different weather conditions and altitude levels. Engineers record large amounts of data to verify performance and safety standards. During flight tests, any issue or abnormal behavior is analyzed and corrected. Sometimes small design adjustments are made to improve stability, reduce vibration, or enhance fuel efficiency. This continuous improvement process ensures that the helicopter meets international aviation safety regulations. Once testing is complete and certification requirements are met, the helicopter moves to the final inspection stage. Quality control teams carefully inspect every component, from bolts and wiring connections to software systems and cockpit instruments. Documentation is prepared to record maintenance schedules, operational limits, and safety guidelines. After approval, the helicopter is prepared for delivery. Customer-specific modifications may be added at this stage. These include luxury seating, medical equipment, rescue winches, cargo hooks, surveillance cameras, or military defense systems. Each helicopter can be customized depending on the customer's needs. Finally, the helicopter is transported to the customer location. It may be flown directly or shipped in parts and reassembled at the destination. Before handover, final checks are performed, and pilots receive training on operation and maintenance procedures. In conclusion, helicopter manufacturing is a combination of science, engineering, and precision craftsmanship. Every component is designed to work perfectly with others under extreme conditions. From aerodynamic design and material selection to advanced testing and quality control, the process requires thousands of skilled workers and advanced technology. The result is a powerful flying machine capable of saving lives, transporting people, supporting defense operations, and exploring remote areas. A helicopter is not just a vehicle, it is a symbol of human innovation and engineering excellence.